After this programmed ignition system, we remove those mechanical systems with the other systems which we called full electronic ignition system or static ignition system. The static ignition system, there is no longer any mechanical part to be driven, to be in contact in order to get the spark in the combustion chamber. That system, that full electronic ignition system, it have two types. There is two types of full electronic ignition system. This system, as it is full electronic, means we have there is the other added component like ECU, electronic control unity, which will control the ignition system, but at the same, the injection system, of course. When the engine is running, we have the system which is injection system in order. The fuel supply. That fuel supply, it will be used as to produce the mixture, where we will have the mixture of air and fuel. But those mixture will be burned by the ignition system. That ignition system here, with a full electronic ignition system, it will be controlled by ECU. Of course, when you have an ECU, an electronic control unity, we have what we call sensors. For example, engine speed sensors. That engine speed sensor will show us the first cylinder to receive, or the first cylinder of the engine. That first cylinder, it will be ready to receive the spark ignition in order to ignite that air-fuel mixture. Some actuators, as we have sensors, we will have also actuator. An example of actuator, we can say this ignition coil. This is an ignition coil. This ignition coil, it will receive the command or the order from the ECU in order to give the spark, in order to give the high tension to the spark plug. On this system, the full electronic ignition system, it is divided into two types. We have dual coil and we have the single coil ignition system. When you have dual coil, this system, we have one coil will serve two spark plug, means two cylinders. Means when this coil get the order from ECU, it will generate the high voltage. But that high voltage, it will be given to both spark plug. You can ask if two spark plug will get the spark at the same time. This ignition coil will give that spark plug to ignition spark plug because one of these spark plug will be given to a spark plug which is in the cylinder at end of compression. which is ready to be where the air fuel are ready to be ignited. Another spark will go to the other cylinder which is in exhaust. That spark will be the waste spark. But the main spark we need is this, which is go in the cylinder in the end of compression. So this system, it can present some problems because suppose on engine with 4 cylinders, we will get 2 ignition coil. Means one ignition coil will serve 2 cylinders, another ignition coil will serve 2 cylinders. So the problem of this, when one spark plug have a problem, when one line have a problem, the other system, or when this ignition coil have a problem, or the cylinder, the 2 cylinders will present that problem. So that's why we don't need to have this problem of one coil to 2 cylinder. We remove this system to this single coil. This single coil means each cylinder have its ignition coil. This single coil ignition system will have this is ignition coil. This is the line to the spark plug. This ignition coil will be directed to the spark plug. This spark plug, when this system, when you have a problem of one ignition coil, the other 3 ignition coil will make the engine to run in order to arrive in the garage for support. That's why this system have many advantages. One of those advantages, there is no mechanical part, as you see. There is no mechanical part. We need only the signal from the ECU to give order for this ignition coil to produce the high voltage to the spark plug. This system is applicable for one of our engine here. This engine, suppose this engine, if you see, this engine have 4 cylinders. As its ignition system, it is full electronic. Those 4 cylinders, each cylinder will have its ignition coil in order to ignite the air-fuel mixture. So this system, as you see, there is those cables, they are from the ECU to give the signal for this ignition coil. So on this system, we have this ECU. This ECU will control the same ignition system, the same also the fuel system. The purpose, remember that, the purpose of ignition system is to ignite the air-fuel mixture in the combustion chamber, especially in the cylinder which is in the end of compression. This system, we will have also this dual coil. This dual coil also, it is applicable to the engine, of course. This engine, it have 2 cylinders. As you see, it have also 2 ignition coil. Those ignition coil will serve 1 in one cylinder, another to another cylinder. This one, this will serve 2 cylinder, number 3 and number 2 and number 3. This one will serve number 1 cylinder, number 1 and number 4. So, note that when this ignition coil presents a problem, it will be on 2 cylinders. That's why we need single ignition coil. Let's show you in this system, let's show you inside this we can get the spark plug. The spark plug, we can open it and show you how it is connected on this ignition coil. Okay, this is the spark plug. This spark plug will be connected on this ignition coil. Means each port of ignition, this ignition coil have this spark plug, own spark plug. That's why we put it in this engine. So let's have a small turn on this system to show you the complete ignition system diagram. Here we have, of course, the battery. All of those are the parts of ignition system. This ignition system, it is programmed ignition system. The programmed ignition system, I told you that it still presents some inconvenience, which is the rotor, which still rotates. This system, the identification of parts, we have this like ignition switch. Of course, we have 3 positions on this ignition switch. The first position, it is in lock. The second, it is in accessories. The third, it is in ignition. When we put on signal or on indication, we allow our ignition system to get the current, especially the primary current, the primary system in the ignition system. So, on this system, we have also this ignition coil. There is an ignition coil in touch with this igniter. This igniter will control the ignition, will control this ignition system. This igniter will control that transistorized ignition or transistorized component. I told you that we have inductive path generator, we have Hall effect, and we have optical sensor. All of those replace what we call the contact point. But this programmed ignition system, we can get the Hall effect inside. So after this ignition coil, we have this igniter. This igniter, it is in touch with this ECU, this electronic control unit. This electronic control unit will control both ignition system and the injection system. Then, After having this, the control of this ECU and in touch with this igniter, they will give the command or the signal to the ignition coil in order this ignition will supply the high voltage with this high tension cable to this distributor. This distributor will get, of course, the high voltage to distribute to each cylinder. Suppose if you drive like this, means we are driving our distributor. We are driving our rotor to the or of contact of distributor. Then, when the rotor is driving, suppose the rotor is on this position, we have our rotor which is driving in clockwise. This rotor at the second will give to this port. This port will give also to the specified spark plug. So, we have here, suppose this is an engine. Suppose here it is inside the cylinder, combustion chamber. Each ignition coil, it is open inside the combustion chamber. That's why we have this high tension cable from this distributor to each cylinder. To conclude, note that as the contact point or conventional ignition system present many problems, we replace it by transistorized ignition system. That transistorized ignition system is divided into 3 types. Those 3 types, especially only one component of each will replace that contact point. Where we have that contact point can be replaced by inductive path generator. The contact point can be replaced by Hall effect sensor. The contact point can be replaced by optical sensor. So, as that system still with the mechanical part, distribution of course of the high voltage and some component which are mechanical for the advance, it is replaced by programmed ignition system. Those parts of advance on the engine will be replaced also by what we call cartography, where it will manage the speed and the road. It will set the ignition point according to the information from the road of the engine and the speed of the engine. So that as it still present the problem of distributing the high voltage distributor, we need to remove this distributor in order to remove all mechanical parts to make our system smooth. That's why we go to this full electronic ignition system. This full electronic ignition system, where we have dual coil and single coil, all of those, there is no longer mechanical part, there is no longer the mechanical part wheel, and there is no longer any contact band. Thank you.